Good morning, everyone. I hope you're having a great Monday morning. I hope you had a good weekend. And today we begin our second to last unit of the year, maybe third to last, but we'll see where we're at with this. But we're getting close to the end, everybody. Getting close to the end. And this is one of my favorite units, statistics. Probably one of the more layman's terms units that you're going to have. I mean, when by layman's terms, I mean it's going to be the kind of math that you see more often in everyday life than most of the other maths that you work on through your careers. Statistics are everywhere, percentages, averages on your phone, on TV, everywhere you go, you see this stuff right here on billboards. So you need to make sure that you have your calculator for this, or get the TI Smart software that I emailed to you and put on the stream, or not emailed, I put it on the stream for you. Get a license if you don't have a graphing calculator, and get the license to it because I'm going to be using it today. All right, so it says find the mean, the median, and the mid-range. You've been doing this since middle school, finding means and medians and so on and so forth, and modes. So we're going to learn about mean, median, mode, range, and interquartile range today. Find the mean. How do you find the mean of anything? You just add stuff up and you divide. So if I add up all 5 of those numbers, it adds up to 430. And if I divide by 5, I get an answer of, what is my answer going to be? 85. Okay. 85 right there. I'm sorry, 86. Having a tough time reading my own handwriting. Okay, find the median. All right, how do you find the median of a set of data? So to find the median, first, arrange the data in order. That's step number 1. Step number 2, for an odd set of data, it's just the middle number. For an even set of data, it's the mean or the average of the 2 middle numbers. So first and foremost, let's take this data and arrange it in order. Okay, so I'm going to do 77. It's almost arranged in order already. 84, then 86, then 90, then 93. Okay, and let me set something up right here so that I can, there we go. Now I have freedom to change colors of my pens and do all sorts of stuff. All right, so first and foremost, my median, there are only 5 numbers here. So lowercase n represents the size of your sample. That's 5, that's an odd number. And the middle number is 86. So my median is 86. Write the numbers from least to greatest, identify the middle number, 86. Sorry, so there it is. And so find the range. The range is nothing more than the maximum number minus the minimum number. And so the maximum number is 93. The minimum number is 77. And what is that max minus the min? It is going to be 16. Boom. All right, so arranging the numbers from least to greatest, that's what I did right there. Okay, the interquartile range. Now, the range is the absolute maximum minus the absolute minimum. The interquartile range is the biggest quartile minus the smallest quartile. Question is, what are the quartiles? What is a quartile? Quartiles quartiles, there we go. Divide the data in 4 equal parts. Divide the data into 4, that's a 4 right there, equal parts. Kind of makes sense, right? Quartiles, quarter, 4. The thing is, how do you divide the data into 4 equal parts? Let me use a different color pen right now. Okay, let's use blue. Okay, All right, let's go to blue right here. So there's Q1, there's Q2, and there's Q3. Guess what, everybody? The median equals the second quartile. The median is the second quartile because the second quartile is smack dab in the middle of the set of data. Q1 is a quarter of the way through the data, but how do I get a quarter of the way through the data? There's two numbers here before the median. Guess what? I just averaged them. The average of Q of the first two numbers will be where Q1 is. Then Q3 will be the average of the second two numbers. Q3 is right there. So how do I find Q1? I take the 77 plus the 84, and I divide by 2. And if I take 77 plus 84 and divide by 2, I get 80.5. Then let's scroll up. How do I find Q3? I take 90 and 93 and average them. So 90 plus 93 divided by 2 is 91.5. So I have 80.5, 91.5. And to find the interquartile range, I just do Q3 minus Q1. So 91.5 minus 80.5. And I get an answer, and that answer is 11.5. This is going to be an important piece of information for tomorrow as we get into data and outliers. Okay, so that's everything on the first page. Would you like to know how to find these same pieces of information by using your calculator? Of course you would, and I'm going to show it to you right now. You can watch this video as many times as you need. Either get out your graphing calculator or load this onto your screen. It is the TI Smart View that I gave you the product license for free, or at least the website to get the product license for free. You really, 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 really should have this for this unit. It's almost imperative. All right, because watch the cool stuff I'm going to show you. Everything from this unit is going to stem from the Stat button. So hit Stat, and then just hit Enter. And a series of empty lists might pop up. What you're going to do is you're going to put the first, or the 5 numbers in that you got right here. So watch what I'm going to do. I'm going to put in 77, hit Enter. Oops, let me scroll back up. 77, and hit Enter. Don't go too quickly, as you can see. Then 86, and hit Enter. Then 84, hit Enter. 93, hit Enter. Mr. Clody, do you need to put them in numerical order? You don't. That's the great thing about a graphing calculator. So watch this. I am now going to, now that I've entered the 5 numbers into L1 of my calculator, I'm hitting Stat again. But notice across the top, there's Edit, there's Calc, and there's Tests. I'm going to arrow to the right, so it goes to the Calc list. And the very first item says 1 var stats. That represents or stands for 1 variable statistics. What the heck does that mean? It means give me all the information on 1 variable or 1 list of data. We already just entered that list of data, so just hit Enter. And where is that list of data? It's in L1. So just go down to Calculate and hit Enter. Don't worry about frequency list. There's no frequency list. And look what pops up. All right, so there's something that I haven't taught you about yet, symbols for the mean. This X with a line over it is called X bar. And when we get back to the other sheet, I'm going to write that down. X bar represents the mean of the data. Hey, it's 86. How cool is that? But notice there it says you can arrow down, so arrow down right now. Arrow down, arrow down. Notice it says n equals 5 because there's 5 pieces of data. The minimum is 77. The first quartile, we just did that by hand. It's 80.5. The median, we did that by hand before. That's 86. The third quartile, we just did it by hand, was 91.5. The calculator does all of it for you. How cool is that? And the max is 93. So if you have a graphing calculator, these calculations can be done for you. The mean is right up here, X bar. Scroll down, and you'll have all the information you need to find the range and the interquartile range. Cool beans. Let's go back and find out what's next here. So first off, let me scroll up. The mean, the symbol that represents the mean is X with a line over it, and it's called X bar. and that is known as the sample, that's an S, sorry, the sample mean. Why did you put the word sample there, Mr. Cody? Well, there's another symbol that represents the mean of a whole population. We'll get to that. All right, so let's get to some questions here. It says if 90 degrees is placed with 92, will the median change? And let's see. What if we replaced the 90 with a 92? So that means it would go 70, 84, 86, 92, 93. So it'd go 77, 84, 86, 92, 93. Is the number in the middle still 86? Has that changed? No. Will the median change? No for the median. How about the mean? Now instead of adding 90, we're adding 92. So will the mean change? Yes. So the mean does change. The median does not change. The median is not affected by extreme values at all, where the mean takes all numbers into account. And by extreme, 92 is not extreme by any stretch of the imagination, but the middle number remains as the middle number. Why is the interquartile range? By the way, IQR stands for interquartile range. Why is it less than the range? That's kind of obvious. The range is the absolute max minus the absolute min, which are these numbers. And the interquartile range just represents these two numbers, third quartile and first quartile. I'm sorry, third quartile and first quartile, the average of those. Okay, standard deviation, moving along. So mean and median are measures of the center of a set of data. Standard deviation is the measure of the spread of a set of data. And how do you calculate standard deviation? I'll be absolutely honest. You can calculate standard deviation by doing all of this, but I am going to let you in on a little secret right here. Standard deviation, and I'm going to write it. Standard deviation has a symbol just like the mean. The mean is X bar. The standard deviation symbol is S. What I'm going to do is I'm going to take you right back. Notice they're using the same set of numbers, same set of data. So let me go right back to my calculator. Let me go right back to one bar stats. And let me scroll back up. And I want you to look at the symbols on the way down. X bar was the first symbol, then sum of x's, sum of x bars, and then look at the fourth symbol down. It's the letter S. I am not going to have us calculate standard deviation by hand. If you have your calculator, graphing calculator, you're going to be able to do this. And the standard deviation S is just 6.12. So guess what? I'm going right to my list right here. And my standard deviation, 6.12. And my median, my mean, I'm sorry, equals 86. We just got that from above. So the mean is 86, standard deviation, 6.12. Kidding me, Mr. Lloyd, that's all you got to do? That's it. All right, so comparing statistics, and there's a lot of stuff right here. So let's read this right here. It says, the tables below list the averages of players, average ages of the players on 15 teams randomly selected from the 2010 teams in the NFL and Major League Baseball. Compare the average ages in the NFL players versus the average ages of the Major League Baseball players. And there's a lot of data there. So you would want to print this out and work it on through. And it shows you right here, a couple things on the graphing calculator. So why don't we do that right now, shall we? I'm going to take the data and I'm going to work it through just like you. All right. So let me show you how to do this on the calculator. First and foremost, I can clear this screen out. If I go to Stat and I go to Edit once again, you just hit Enter. Do you see how L1 is still there? It will be there forever. It'll be there for all eternity unless I get rid of it. Notice how I can arrow to the right from L2, L3. I could also arrow up so that L1 is highlighted. When L1 is highlighted, press clear, and then press enter, and then L1 becomes clear. Do not press delete, press clear, and then enter. So I'm just going to start entering the data for the NFL teams. 25.8, 26, 26.3, 25.7, 25.1, 25.2, 26.1, 26.4, 25.9, 26.6, 26.3, 26.2, 26.8, 25.6, and finally 25.7. After I do that, I'm going to go to L2, and I'm going to put the Major League Baseball players in L2. You're allowed to do that? Sure. You could put in as many lists as you want. 28.5, 29, 28, 27.8, 29.5, 29.1, 26.9, 28.9, 28.6, 28.7, 26.9, 30.5, 28.7, 28.9, and finally 29.3. Okay, I'm now ready to go to Stat, then arrow to right to Calc, and I'm going to do one var stats, and I'm going to do it one at a time. I'm going to do it on, notice it says L1, so that's the NFL players. Go to Calculate. So my mean is 24.38. That's the average age of the NFL players in 2010. Standard deviation, measure of spread. Now, what does that mean, standard deviation? What does that number mean? 6.13, 6.126, so 6.13. Is that a big number? Is that a small number? What does it represent? You're asking a wonderful question. I'll get to that in just a bit. So the mean is 24.38, standard deviation 6.13. Let me go back to my sheet. So 24.38. So for the NFL player, the mean is 24.38 years old. 6.13 is the standard deviation. So all I got to do is fill that in. Okay, so now let's just arrow down. My median is 25.9, and my Q3 is 26.3 and 25.6. So let's go back. So my interquartile range for them is 26.3 minus 25.6. And what is that right there? 0.7. And the median was what? 25.9. Just double checking. 25.9. There we go. All right. I did everything for the NFL. Now let's go to MLB Watch. Let me go back to Stat. Let me go to Calc and one var stats. Now, where did we put our Major League Baseball players? Not in L1. I cleared it out, but you're going to hit second and then look above the numbers 1, 2, 3, 4, 5, 6. Do you see L1, L2, L3? We put our Major League Baseball players in L2, so hit second and then L2. Now we're going to do one var stats on L2 and find out the Major League Baseball players. Hit enter. Ooh, average age of Major League Baseball is 28.62. Standard deviation is 0.94. So 28.62 and 0.94. 28.62, and 0.94. The one thing you need to know about standard deviation as a measure of spread, the larger the number, the larger the spread. So Major League Baseball players on average are a bit older, but their spread is a lot smaller. So people might be only 25, 26, 27, 28, 29, 30 in a small window. The average age of the NFL player is 24, but standard deviation is a lot bigger. So you might get 18-year-olds in the NFL, and that they have to go to college. So 21-year-olds, but all the way up to the Tom Brady's of the world who are 42. So it looks like the standard deviation is a lot larger for that. All right, so let's finally go back to the calculator here, and then let's scroll down. The median is 28.7, and then 29.1 minus 28. Isn't that just 1.1? It is. Q3 minus Q1 is 1.1. So 28.7 is the median. 28.7 is the median, and 1.1 is the interquartile range. Okay. So that's the deal with that. I know I'm not answering all the questions, but I just want to give you the nuts and bolts of how we get the answers for this right here. Okay, that's the end. It was a long lesson right there. Get the calculator app or have a calculator handy and practice this. Watch the video as many times as you need to understand how to put the calculator stuff in. Okay, bye everybody.